we're now going to use the rational zeros theorem. So first things first, let's officially define the rational zeros theorem. And the rational zeros theorem says if p of x is equal to an xn plus an minus 1 x to the n minus 1 plus a1x plus a naught is a polynomial function where all of the coefficients are integers with integer coefficients an to a0. These are all of these are integers, so they're allowed to be positive and negative. And p divided by q is a rational number in lowest terms. Then p is a factor of the constant term a naught, and q is a factor of an, the leading coefficient. And very specifically what this means is that all possible real zeros will be of the form p over q. Or rather, all the possible rational zeros, not real. There will be some real numbers that don't follow this. But we can find all of the rational zeros by taking only factors of the last number divided by factors of the first number. And that greatly limits the playing field of numbers that we need to look for. So let's look at a couple of examples just to demonstrate what we're talking about here. So f of x is equal to 2x cubed plus 3x squared minus 6x minus 8. And what we're going to do is we're going to use the rational zeros theorem to find all possible rational zeros. So we're going to identify an. This is a3, which matches our degree, so the n is the degree. And this is a naught. And so what we're going to do is we're going to find out all the factors of a3. The possible factors are 2 and 1. That's it. But for a naught, we get 8, 4, 2, and 1. These are all the possible factors. And so our possible zeros are all the combinations of these numbers divided by all the combinations of these numbers of both signs. So we're going to add a plus or a minus. And I like to start with the small ones and work up. So we're going to do 1 over 1 plus or minus 1 over 2. So that's this one now over both of these. And then plus or minus 2 over 1 plus or minus 2 over 2 and that's both of these now, this one over both of these, plus or minus 4 over 1 plus or minus 4 over 2, plus or minus 8 over 1, plus or minus 8 over 2. And now if we look at this, I want to be very, very clear. Notice that the 2 over 2 is the same as 1 over 1, and so I only need to list it once. And 4 over 2 is 2 over 1, which again I have, so I only need to list it once. And 8 over 2 is 4 over 1, so I only need to list it once. And so my possible answers in this case are 1, plus or minus 1/2, plus or minus 2, plus or minus 4, and plus or minus 8. There's 1, 2, 3, 4, 5 possible rational zeros of both signs. So there's 10 total numbers that I need to check here. And so those are our rational zeros. Let's just do one more example just to make sure. Suppose that we have g of x equals x to the 4th minus 9x cubed plus 3x squared minus 5x plus 16. Well, we start with the first one. Notice there's no number written, so we give it a 1, and that's a4 in this case, our highest degree. And our a naught is 16. So a to the fourth is only 1. That's the only factor of 1 there is. A naught, though, is 16, 8, 4, 2, and 1. So our possible zeros are all of these divided by all of these. Well, there's only 1 over here, so all it is these, but we have to write it out with plus or minus signs because they might be positive, they might be negative. Possible rational zeros, rather. And so we get plus or minus 1, plus or minus 2, plus or minus, not 3, 4, plus or minus 8, and plus or minus 16. 1, 2, 3, 4, 5. Again, there's 10 possibilities here. 5 total numbers, but each sign could be a possibility. So that's how we find it, is factors of the last number divided by factors of the first number.